you to send me that video.
Okay. Send you that video. Okay, I need your little probe here.
Please probe it.
Okay. Yours has got a very small, okay, this right here. When I pull it apart, okay, that's your lateral ventricle, okay, and it has this membrane. Oh, I've just busted it. There's a membrane that you can kind of see. Let's see if you can see it on this side. Nope. There's a membrane that they'll have like a probe sticking sideways. Okay, that's not it. That's your choroid plexus. Those are the cells inside that make up they produce cerebrospinal fluid. Okay, so if it's sticking straight in like this, they want lateral ventricle. Okay. If it's sticking sideways and it has like a membrane over it, it's septum pellucidum. This white part that comes above the lateral ventricle is your corpus callosum. Okay. Then it cut off. Okay.
Sorry.
So then here you've got your thalamus, and down towards the bottom is hypothalamus. Like I was telling them, one of the terms is intermediate mass. It's like a little spot in the middle of your thalamus that you can't see on here. Okay. Then right back here, see this little guy? Right to the back of the thalamus, that's your pineal gland in the epithalamus. Okay. Then, see your lateral ventricle, you come down here, there's kind of like a groove through there. That is your cerebral aqueduct, okay? And it ends up down here at the base of the tree, fourth ventricle, okay? So the liquid, comes through here, goes down through a third ventricle that you can't really see, down this cerebral aqueduct, fourth ventricle. So then this part here, on either side, midbrain. You've got corpora quadrumina of the midbrain, and then midbrain. And then you've got pons and medulla oblongata. And then right down here where you've got the little, that's your spinal cord. Okay? Now, this is your cerebellum. Of course, they're going to ask you that. They're going to ask arbor vitae. Okay? If it's in here, that's your optic chiasma, because that's where this is cut in half. Okay? Where they crossed. Okay? This would be optic chiasma. This is your pituitary gland. So if it kind of goes back, it's optic chiasma, pituitary gland, pons. Like you'll see in all the models, the pons looks like it's huge and bulged out, but really on these, it's really not so much. So it's midbrain, pons, medulla oblongata. And the water boy, okay? Then there will be one that's together like this. You'll have to be able to label olfactory bulb and optic nerve on this one. And 1, 2, 1, 2. This one is way out front here because it's sticking up above your sinuses. It's for smell. This one is for vision because it crosses over here. Okay?
Sounds like a spider's fang.
Alright? And so they may have one that's turned over like this, and they'll go, and that would be your cerebellum. And then if they say name the lobe,
The frontal.
frontal, because it's way up here towards the front, towards your olfactory, because your brain stem is going down your back. Okay? So they're going to do probably frontal, cerebellum, and then, like I said, they'll turn it over and you will have multiples of these. But expect lateral ventricle, septum pellucidum, corpus callosum, thalamus or hypothalamus, pituitary, optic chiasma, cerebral aqueduct, fourth ventricle, that arbor vitae. Learn it, live it, love it. Okay? All right? Sound good?
Mm-hmm.
And you'll see that. And that's what I was talking about here, is if I were to stick this probe kind of underneath, see the clear, that's your pia mater, okay?
Oh, is that
it's like shrink wrapped.
That's how they would ask.
It would be like that. They usually don't have it. Okay. This one though, you can bet
What
on
about
it.
the pia mater?
The arachnoid mater in the middle, you can't see it. It's very delicate and webby. That's where it gets that arachnoid name. Spider-like, spider-webby. Okay? And then this you cut down with your longitudinal fissure. This right here is your transverse fissure, the one that goes across the back here.
All that part of that.
Okay.
Mm-hmm.
All right. See, it's not so hard. It really isn't. Well, if every brain looked exactly